Hi Kate, good morning. So, tudloan di ka ito imong assignment. Kahapon ka to bitaw imong gisend. Sayon ra kay ito na ko, Kate. Char lang. Nawito si Tito Clyde. Tudlo ni mo.
So I will just give you one example for each problem that you have. So our first assignment is to look for the nth term given sequence, first set of terms of the sequence, and your second set of assignment is to generate some first, second, third, and maybe particular nth term, which is an example of 16th term like that. So let's start with the number 1. So a sequence could either be arithmetic, geometric, hyperbolic, and actually there are actually a lot of type of sequences, but let's start with the easiest one, which is the arithmetic sequence. Here's an example of the arithmetic sequence. Aside from this, 5, 10, 15, 20 is also an example of arithmetic sequence. 3, 6, 9, 12, 15 is also another example of arithmetic sequence. So as you can see, if you're going to observe 7, 11, 15, 19, this is an example of arithmetic sequence because as you can see, 7 to 11 there is a difference of 4. You can actually add 4 to 7 to obtain the next term. 11 will become 14 also by adding 4, so the interval is 4. There's a common difference 4. So this is actually our first term, the 7. Second term, we have the third term for 15, and then we have a sub 4 for 19. So we can actually predict what is our fifth term by adding 4 to 19. So that will be 23. And of course, our sixth term, if we're going to add 4 to 23, and that will give us 27. But you are asked to find the nth term, and the nth term is denoted as a sub n, which is equal to an expression of some sort of a formula that when you substitute the n by 1, you get 7. Substitute n by 2, you'll get 11. By 3, you'll get 15. By 4, you'll get 19, and so on and so forth. So basically, to investigate what's our possible nth term, we may use the observed difference, which is actually 4 here, and start with an initial expression. So maybe we can use the 4 and make 4n as our initial expression, because when we let n be equal to 1, so that will give us 4 times 1, that will give us 4. When we let n be 2, so that's 4 times 2, you will get 8. If we let this by 3, 4 times 3, 12. So as you can see, we are generating a sequence, but this sequence is not actually our given sequence, but this has an interval of 4. Okay, so what we can do further is to improve more to get the actual sequence. So maybe we need to do something with the expression 4n so that the generated terms will be the actual 7, 11, 15, 19. So maybe by just looking at 4 and 7, we need to add something to the 4 so that it will become 7. What's the number? Yes, no, that's 3. So that if n is equal to 1, so our solution will be 4 times 1 plus 3. 4 times 1, 4 plus 3, 7. So you get the correct answer for a sub 1, which is actually 7. Now if n is equal to 2, so 4 times 2 plus 3, 4 times 2 is 8. So actually wala na appeal. 4 times 2 is 8 plus 3, 11. And there you go, you obtain now your second term. And if n is equal to 3, 4 times 3 plus 3, and you get 15. And that is your a sub 3. And last but not the least, if n is equal to 4, 4 times 4 plus 3, 4 times 4, 16 plus 3, 19. There you go. We now have a correct answers for the first 4 terms. If n equals 1, you get 7. If n equals 2, we get 11. If n equals 3, we get 15. And if n equals 4, we get 19. So that means our expression here is correct. 4n plus 3. So our nth term is a sub n, which is equal to 4n plus 3. So this is our nth term. Let's go to the next example. So, in contrary with our first example, in this number 2, you are already given the nth term, and our nth term is a sub n equals 2n raised to the third power minus 1, or 2n cubed minus 1. And you are asked to generate first 3 terms, so that means we have to get the a sub 1, a sub 2, a sub 3, and maybe you will be asked to solve for the a sub 16 or the 16th term. 16th term, or it's basically a sub 16. Okay. So to solve for the first term, we simply look for a sub 1. Okay, a sub 1. And this is just simply substitution for n and let b equal to 1. So that will become 2, and let the n be equal to 1. So 2 times 1 raised to 3 minus 1. And of course, we have to simplify first this expression, 1 raised to 3. 1 times 1 times 1, that's still 1. And 2 times 1 is 2 minus 1. And our first term is 1. So that means our first term is 1. Our a sub 1 is equal to 1. Next, we solve for our second term, which is a sub 2. And of course, following the formula, 2n, and let be that 2 cube minus 1. And of course, 2 cube is equal to 2 times 2 times 2. So that's equal to 8. So 2 times 8 minus 1. And of course, 2 times 8 is 16 minus 1. So that's actually 15. So our second term is 15. Our second term is 15. First term is 1. So our second term is 15. And to solve for the third term, which is a sub 3, so using the same formula here, 2n cubed minus 1. So 2 times 3 raised to 3 minus 1. So 3 times 3 times 3, or 3 cubed. 3 times 3, 9 times 3, 27. So then multiply that out. 27 times 2 is 54 minus 1. So our third term is actually 53. So that is our third term of the sequence. So our third term is actually 53. And then our 16th term, using the same procedure, we use a sub 16. And 2 times 16 raised to 3 minus 1. I'm not that fast to multiply 16 by itself 3 times, so we need a calculator.
I need a calculator.
So 16 raised to 3 is 4096. 4096. And 4096 times 2 is 8192 minus 1. And our 16th term is 8191.
That's it.
So if you have questions, Kate, hit like and subscribe to my channel, and maybe you can send me further questions about this topic.
Easy peasy.
Bye. Peace out. Okay,